All right, folks. So I want to go over this problem here. It is the last problem in one of the SAT tests. I believe it's test 9. So we have this problem. It says the number of international tourist arrivals in Russia in 2012 was 13.5% greater than in 2011. Okay, the number of international tourist arrivals in Russia was k million times more in 2012 than in 2011. And what is the value of k to the nearest integer? We're given the international tourist arrivals in millions, okay, for a bunch of countries, and we have the years. We have 2012, 2013. We don't have 2011 here, okay, so we're not directly given the 2011 number, but we are given 2012, right? And we're asked about Russia, so it should be that the only number we care about is 24.7 for Russia, right? Let's go back here, and let me show you how you should maybe think of starting this problem. And, you're given information in here. And even though you might not know right from the beginning how you're going to solve it, how you're going to find k, you should start using the information here to set up math, to set up logic that you know is true. And hopefully, at the end of that setup, you find some sort of solution, okay? So, okay, let's get started with that process. So the number of international tourist arrivals in Russia in 2012 was 13.5% greater than in 2011. Okay, so I'm going to set it up like this. I'm going to say 2011 here and 2012. All right. So I'm going to say in 2011, there's some number, n. Okay, n million tourist arrivals. I don't know what it is. But what I do know is that in 2012, the number is now going to be n times 1.135. Okay, that's using this piece of information. In 2012, it was 13.5% greater than in 2011. Okay, if you don't know where this 1.135 comes from, okay, let me explain it a little bit. Okay, so if in 2011 we have n, okay, and we wanted to add 13.5% of n to n, right? Because we're told that 2012, 13.5% greater. Okay, so if we're going to add 13.5% to n, okay, we're going to multiply, we're going to add n multiplied by 0.135. And 0.135, okay, is the same thing as 13.5 divided by 100, right? So this right here represents 13% of n, all right? And we basically just can combine these things here. So we can factor out the n, right? We can take out the n, and that's just giving us n multiplied by 1 plus 0.135, okay? Which is the same thing as n multiplied by 1.135. All right? So typically in percentage problems, if you're told, oh, I want to know the value once it's been increased by 10%, you're going to multiply by 1 point whatever that extra percentage you're going to need. I just said 10%, so it would be 1.1 if you wanted to increase by 10%. Okay. If you just multiplied by, like in this case, 0.135, then we just have the 13%. But we want the 13% plus the value from before. So we want 113%, essentially. So 113%, meaning 1, and then adding 13% is 1.135. Okay? All right, so that's where this 1.135 comes from. Okay, so we use one piece of information. Okay, 2011 and 2012, n times 1.135. Okay, let's see. Then the next line says the number of international tourist arrivals in Russia was k million more in 2011 than in 2012. Okay, so in 2011 we have n, then in 2012 we have n plus k. Okay. So now we have two ways to write the 2012 number. Okay, and then we want to find the value of k. Well, now let's use our final piece of information, which is the first piece of information that we identified. Okay, and that is that in 2012, our number here for the number of international tourist arrivals is 24.7. Okay, so 24.7. So all of these numbers in this underneath 2012 here, they are all equal. Okay, they are all equal. So what you essentially have is n times 1.135, okay, that's equal to 24.7. And then you also have n plus k is equal to 24.7. Okay, so now you've set up a linear system of equations. Okay, you have two equations and two unknowns, and therefore you can solve for both of those unknowns. Of course, we are concerned with k, so first thing that we're going to do is solve for n. Okay, we're going to solve for n using this equation here, so let's do that. So I'm going to do that just over here to the side. So we have n times 1.135 is equal to 24.7. All right, so then n is going to be 24.7, okay, divided by 1.135. Okay, and now we're going to solve for k. So first thing I'm going to do, I'm going to use this equation. I'm going to isolate k. So I'm going to say k is equal to 24.7 minus n, right? Just subtracting n from both sides here. Now I'm going to plug the n that we found into this. Okay, so k is 24.7, okay, minus 24.7, okay, divided by 1.135. All right, so let's calculate that real quick. This is going to be 24.7 minus 21. Okay, actually, if we round up, it's 0.8, but I'm just going to do 21.76. All right, and this is going to be pretty close to 3. All right, and we want k to the nearest integer. So our answer for k is simply going to be 3. Okay, so in the end, it's going to be that k is indeed equal to 3. All right, so just a quick recap. What happened there? Okay, I'm just going to change colors real quick. All right, so we have this thing here. We have all this. We had this information, and we have our table here, right? So how you should start with this kind of problem is, one, just start setting up the logic. Okay, so one, just start setting up. Start setting up. Okay, if you don't have a number, represent it with a variable, with a letter. That's what I did. I didn't know what the number in 2011 was, but I just said, whatever, it's going to be n, maybe I can find it later, okay? N in 2011, n times 1.135 in 2012, and then I was able to use that first line. All right, and I did the same thing for the second line over here, using the second line of information. Okay, so start setting up. All right, start setting up. Another thing to note here is that percentages, right? So if we want a 13.5% increase, that's multiplying by 1.135, right? For this reason here, like n plus n times 0.135, okay, that's the same as n times 1.135, okay, it gives us a 13% increase, okay? And then lastly, two equations, two unknowns. We created two equations here, okay, using all the information we have. All right, here are our two equations. Two equations, two unknowns, okay? So then you solve the system. All right. Okay, so I hope that was a good overview of this problem. It's, again, with the last problem of a math session, so it's going to be kind of maybe the hardest thing you'll ever see on the SAT. Definitely up there. So if you can solve stuff like this, you should be good in general.